5-8. It's called analyzing graphs. It basically means you graph. What it means. Graphs polynomials. The prereq skill is something we talked about in December. It's called end behavior. You're supposed to remember how things behave. If you saw x cubed or x to the fifth, you're supposed to remember how they start and stop their days. But how x cubed starts its day? X cubed starts low. It ends at say how? High. What if there was a negative sign in front of that thing? What's it do to it? Flips. It's called a reflection. Negative sign causes reflection. All right. We have an even degree. Maybe something like y equals x squared. You've been looking at x squared for 2 straight months. What's x squared looks like? X squared itself is the parabola, kids. So how does a parabola start in this day? I know. Y'all just not even having a clue what I'm doing with my hands here, are you? Parabola, where are my hands? High and high. What if you put a negative inside in front of that x squared? Low and low. Makes the thing reflect. It's end behavior. Point is there's a lot of things we can figure out before we even start doing something. End behavior is the majority of the graph. It's just the stuff in the middle that's funky looking. All right, we have the definition of a power function. Power function is what a polynomial behaves like. And it's found by doing Milbrath-Math. What we're going to do is we're going to ignore constants in parentheses. We're going to talk about what the power function of this thing is. So if I was to ignore the constants in f of x, just pretend they're not there, and I wrote it out. Anyways, not even write f of x is not. I'd ignore that -4, I'd ignore that 5, and I'd ignore that 3. I'd leave 8 out there. I'm just going to ignore the constants inside. And I do a little Milbrath-Math. I just focus on the x's and put them all together. I have x times x squared times x. I have x to what power? To the 4th. Well, that's an even degree. Positive coefficient up front. How does it start its day? High. How does it end its day? High. It starts high, ends high. And if I had 5 minutes, we fire up our T84s and we plug that thing in. Guess how it would start its day? And how would it end its day? Because it behaves like that power, that leading exponent. Okay? That would actually be the leading piece. If we were to do all the math, it would be 0.1x to the 4th. That'd be the leading piece. What's our power function for g of x? It's -1 times an x that will be squared. So it's really what? Cubed. X times x squared is x cubed. Pencil? Somebody's shutting down on me. Anyways, how's that start today? High. It goes high to low. Just like it appears some of y'all are today. I think you started high and now you're going through that low. Some of y'all are zonked out. That's the idea of a power function. We're only going to do one graph because they all work pretty much the same. But before we do that one graph, we're going to jump to this, the multiplicity of zeros. Jumping right to that. Now, even multiplicity, I'll give you an example of something even multiplicity. We have an example. We have a factor of x minus 2 raised to the 4th power. That's even multiplicity because of its exponent. X minus 2 to the 2nd power would be even multiplicity because of its exponent. Okay? That has a 0, better known as an x-intercept, at x equals what? 2. Change sign. It is repeated 4 times. Exponents tell all. Okay? Repeated 4 times. Now, when it comes to graphing, on the graph, we would touch the x-axis at x equals 2. We wouldn't pass through it. We wouldn't cross it like we usually do with x-intercepts. We'd touch it. It's like that special one, which, by the way, if you remember that example, that was where the exponent was 2. All even multiplicities touch the x-axis. They do not cross it, they touch it. And then we have odd multiplicity. Odd multiplicity would be something like x plus 5, I don't know, to the 5th power. That's an odd multiplicity. If you saw x plus 5 to the 5th power, what are your x-intercept? Or what is your x-intercept? As an x-intercept at x equals negative 5. It happens 5 times. But you can't really show that on a graph. You really can't. You can't do dot, 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 dot. They just cover each other up. It crosses at x equals negative 5. And that's the deal. All odd multiplicities cross the x-axis. And some kids really struggle with things on this. They really do struggle with multiplicity, especially when a factor doesn't have the exponent. Is x plus 3 just written like that, even or odd? It's odd. It's odd. Because what is the understood exponent? Yeah, it's understood. And that's your deal about multiplicities. That's there to help you graph. It's a really easy skill. You tend to see it on EOC, and most of you are zonked out and going to miss it. I really need to know what y'all's plan to pass me is, because last I checked, I'm the one who puts the grades in the grade book. Like, what, do you know my Synergy username and password, and you're going to change them all? Anybody know my Synergy username and password? No. None of you do. What's your plan? Staring at my wall ain't helping. Whatever, kids. Sorry you're so demoralized here. Teachers ain't no better this year with y'all. Not hard stuff, kids. If you don't like it, I want you to take your cell phone and I want you to smash it with a hammer. You have no idea how much engineering and mathematics is involved in everything that you use every single day of your life. You couldn't even eat if it weren't for mathematics. Not possible. No way we can feed this world. Impossible. Might be 100 million people that work in math and engineering and biology. Might. Maybe a couple, maybe 200-300. I don't know. It wouldn't be much. We're in our function on graph. 1/6 x plus 3 times x minus 2 squared. What are your zeros? One of them is x equals -3. What's the other one? 2. Now that -3, when we plot that thing and eventually we draw, are we going to cross or touch the x-axis? We're going to cross it. Why? Because you understood one. Cross the x-axis. It's a cross. How about x equals 2? It's a touch. Touch the x-axis. Anyways, I can plot those pretty easy. That 3 over 2. There's two things. You always want to go after the y-intercept on these. The y-intercept is easy to find. How do you find a y-intercept? What do you plug in? Let x be what? 0. Oh, you just plug in 0. Your y-intercept is 1/6 of a 0 plus a 3 times a 0 minus a 2 all squared. You could use a calculator for that if you wanted to, or you do it in your head, I don't care. 0 plus 3 is 3. 0 minus 2 is -2, and -2 squared is 4. What's 3 times 4? 12. How do you take a sixth of something? When I had rubber bands, I do this show like we do the young cattle. How do you take a sixth of something? Divided by 6. Hey, you could keep your balls. Good job. You're worthy of keeping them. Divided by 6. What's 12 over 6? 2. Only we can do stuff like that. Just have that little bottle or little glass bottle full of castration bands up here. Every time you flunk a test, all that sucker on you.
I wish the things get done on this heartbreak.
Well, that's bad question, that's not going. When you let them go to baseball.
You know why we do that, right? Why do you castrate a
To
pig?
make the meat taste better or whatever, just the wild out.
They
Quite honest.
get heavier. And yes, they are easier to control. Would you be easier to control if someone stick your balls on?
No, no testosterone.
You have no testosterone.
That's where it comes from? Yeah.
No,
It's
it
just
comes from our brain.
How are those animals?
Males get testosterone from their testes.
Yeah, yes.
Anyways, you got that. Now, we're going to skip step 4. Step 4 is end behavior. You need to think about your power function. How do you call that power function? What do you ignore?
The
Constants. So that would just be an x there. And that'd be an x that's squared. What is your power function? 6x cubed. It's positive x cubed. How's it start? Low. First line is high. I like to use my hands for this stuff. It's how I memorized it a long time ago. Low to high. I've seen me do it up here. Still do it to this day. I've got more of me involved in this stuff. Helps. Anyways, so we know all of this. We know all of this. This is the interesting stuff. It's this little bit of stuff in the middle. All you gotta do is make up some, plug in some x values. Wouldn't you like to know maybe what happens? Well, I know you don't want to know, but if you were interested, wouldn't you like to know what happens when x is -4? Yes. What else might you want to know if you were interested in the problem? 3 would be a good one. And all this little stuff in between. -2, -1, 1. That doesn't take but just a minute or two to figure out, kids. You've got a TI-84 in front of you. You know how to use a storage feature on the calculator. Do it. I'll walk you through one of them. I'm going to take the 3 at the bottom. I'm going to hit STO, X. And then I'm going to type in the equation. As it's written, parentheses, 1/6, close parentheses, X plus 3.
You didn't vote.
I didn't think you did. Parentheses, X minus 2, all squared. I got a 1. And again, y'all not doing it. You missed the first question on the quiz because you don't know how to use a storage feature. If your plan is to do nothing this 6 weeks and make it 12 and use Khan Academy, it's not going to fly with you. You got to try in class, kids. You can't just sit there and do nothing. Anyways, you guys plug in some other numbers. So I don't have to sit up here for 2 minutes and do it. I plug in 3.
What is
0.66 2/3. When you see 0.66, you're at 2/3.
-1/3.
Go ahead, Jay.
Why do you do that? Or, as long as you put the formula in.
You just did the storage. You didn't bring up the old work. Bring up that equation work, and you got to retype it for a second minute. You never type in the equation.
Yeah, I don't have that point.
You got to type in that equation. The one you corrected me on? What you got, Austin? For asking. -4 is -6.
-2 is 8/3.
8/3. Probably have 2.66. 8/3. That's all you need to know to graph this thing. -4 was -6. About right in there. Is that point about where you think it should be? You know what end behavior 7 happened? That's good. -2 is 8/3. That's 2 2/3. A little under 3. Except for that wrong spot. There she goes there. -1 was 3. You already know what 0 is. 1 was 2/3. And 3 was 1. All you gotta do is connect the dots, kids. Start from left to right. Don't ever pick up your pencil. These are not straight things. They're all curvature. The only things in here that you graph that are straight are lines and absolute value. I missed my initial arrow, but okay. It was in the wrong spot. That's it. That's how you graph polynomial. The usual questions are, I don't know where you came up with the x values. I didn't know them. I didn't know it was there. That's how I came up with them. Nothing special about it. I wanted to know what was there. Nothing more. They told me how to connect all the dots together. If we typed this in a calculator, we'd see the exact same graph. That's what it would look like. That's all a calculator does is plug in numbers. Talked about that one. We're going to skip this one. We're going to jump to what's called turning points. Turning point is simply where the graph turns. That's all it is. Where a graph turns. Nothing more. I actually have them labeled with dots for you. Trying to make it a little easier. How many places or how many places does this graph turn? 4 of them, right? If you need me to point it out, I can point it out. That's the turning point. We'll abbreviate it TP. There's turning point. There's turning point. And there's one. Now, we tend to call these things in math, we use the term local max or local min. That guy right there, we call a local minimum. because in that region of space, he is the lowest value. Okay? This guy right here, I would call a local what? Maximum. Because in that region of space, that's the high point. You guys are already familiar with maximums. Should be. We've used that function numerous times on the calculator. All right. So you guys said that this thing had 4 turning points. I agreed with that. It had 4. The first thing we talked about today was end behavior. So let's answer that question. Based on how the ends behave, is it of even degree or odd degree? Odd. Evens start and stop their days the same way. This is odd. That means that it could be something, could be an x to the 3rd, an x to the 5th, x to the 7th, whatever, right? Just something with an odd power. It could be any of that. Now, I'm going to tell you right now, there is a relationship between turns and power. There's a relationship between turns and power of the degree. There is. And to help you kind of establish that idea, we're going to do example B on the next slide. And this is a calculator thing. It says use your calculator to find the coordinates of any local maxima or minima for the given equation. We're going to do example B. So I'm going to go to my good old trusty TI-84. Board cards. Uh-oh. Oh, we're in so much trouble. Oh, not funny. Okay. Why you said anything equal to 0? Did it ask you to solve for x? Nope. You graphed the thing. So again, you're looking at example B. You ought to be able to see your piece of paper better than mine. My calculator up here. So maybe you should type this in your calculator instead of sitting there wondering why you're flunking everything. I don't know, y'all are just so... Half of y'all just act like there aren't consequences. It really baffles me. I hope and pray you're not 30 years old one day and wonder why your life is such a disaster. I'm not saying that because you don't like school you won't have a good life. I just hope that that attitude doesn't carry over. You need to figure out a game plan, kids, soon. You're almost adults. Anyways, I've typed it in. Hopefully so have y'all. How are you supposed to Zoom? Zoom 6. Now, on example B, we actually didn't see the whole picture. How many turning points are there? There's 3. You ought to be able to figure out that this graph falls, and then what's it do? It turns and comes back up. We're going to go after that. We're going to view that. I actually want to see that turning point. What do you need to adjust? Well, I'm in. Make up a number. Negative 30? Okay. You took a guess. MJ, have you typed any of this stuff in? Okay. Did 30 work? I'm not going to go with 35 either. Go bigger than negative 30.
45?
Negative 45 works. Just guess. Window. Again, hit the window button. Negative 45. Don't increment in such small numbers, Tyler. Don't increment in such small numbers. Negative 45 according to Madison. That was her guess, and it works. And now you see there's 3 turning points, right? I'll go ahead and type that over on these notes. We'll come back to that later. There are 3 of them. Let's answer the actual questions up here. Find the coordinates of the local max. You should already know how to do that. There's a maximum right there where my cursor is. How do you figure out what it is? Second trace. And what function? No. Maximum, kids. It's called a max. You press enter, and it works the same way it's always worked. You get to the left of the maximum. You might have some stuff in the way of the equation itself. That's no big deal. You get to the left of where the maximum is, and you press what? Enter. Let me get a little closer. Then after you press enter, you get where? To the right. Again, I'm looking, and y'all just aren't doing this. I can't wait 10 minutes for you to do something that I've done with you 40 times for the first time. I am tired of caring about your grade. About 1.11 and 5.11. Only about 10 of you did that. Again, learn how to use your calculator. Go get one from the library. Now, the next part's new. I've never done this with you. It's called a minimum. Local min. How many did you see on your calculator? 2. Maybe you should do this. Adriana, you got it up? MJ, I don't think I saw you do anything when we did the maximum. I see one here. I see one down here. Now, you saw a second trace. What did you see? Minimum. It's really that simple. And y'all are sitting there acting like you know what you're doing. I give you a quiz asking for a minimum. I know full well most of you will miss it. You get left just like on a max, you press enter. You get right, you press enter, and then you guess. And our answers will agree. It's at about negative 0.57 and about negative 6.51. There's a second one, isn't there? I'll find it. I'm really sorry all my guys were too. I wish you did. Is it me? I've been on negative with y'all lately. Just disappointing. That's all. Anybody come up with anything? 3.96, negative 43.04. That sounds right. Here's 2 maxes and minimums. Those do actually have problems with applications in the real world. The problem is when we give those problems, they're going to be word problems, and we just don't look at them. You just gloss over it. All right, so let's go back onto the idea of turning points here. That was a x to the 4th, wasn't it? How many turning points does it have?
Good afternoon. So it's just a couple of announcements. Remember to stay masked up when necessary, wash your hands frequently, and maintain a safe distance from others whenever possible. Remember, let's everyone try to stay healthy and stay in school. If anyone would like to do makeup school pictures, you need to see Miss Montezuma in the library, or you can see Miss Oliver. Senior quotes are due January the 15th, and they must be turned in to Miss Travis or Miss Montezuma. Senior ads are extended to January 15th. Pictures and money will be due and must be turned in with an ASCII. We will be playing Greenfield here at home tomorrow night. Tickets are being sold right now, so players, if you need a ticket, you need to come see Miss Claire. Also, students, if you do not have a laptop and you are interested in getting one, you need to come see Mr. Killebrew, or you can see myself here in the office. Everyone have a good afternoon.
We're still really pushing those things, aren't we? We're not shutting down. Not happening. We made it this far, we're not shutting down. Anyways, I went back to the previous slide. How many turning points did I have? I'm gonna tell you real quick, it can't be X speed. It could be X to the fifth. You know, that was a relationship. X to the fourth had 3 turning points. This could be X to the fifth. It could also be X to the seventh. So let's talk about what turning point theorem is. We'll call it TP theorem. Not the theorem of toilet paper. Turning points. Let's see here. A polynomial is, and wording here is at least 1 degree higher than the number of turning points. Polynomial is at least 1 degree higher than the number of turning points that you see. That doesn't mean because you see 4, it's a 6th degree polynomial, or it's a 5th degree polynomial. You also got to think about ambiguity and stuff too. That's probably Sean. We're going to answer a couple little quick questions at the end, and then we'll be done in here. We'll actually do the bottom question first, then we'll work our way up. Graph of polynomial has 12 turning points. What is the least degree it could be? 13. It is at least. It is at least. Let's put x to 13. It is at least x to 13. Now the questions above are kind of backwards. It talks about a polynomial of degree 5. We don't use the wording at least here. What's the most turning points that we have? 4. At most 4. We can only have 1. That's doable. We only have 2. That's doable too. How about a polynomial of degree 9? 8. There you go, kids. You got your homework already. I highly suggest you do it. Homework is just practice for a test, and your tests haven't been going so well. Huh? You can do that at home. Well, I'm tired of this crap. Why don't you try passing my class? Yeah. Just have Miss Allison send me an email saying it's okay if you're in there.